We now move on to Olivier, who will be talking to us about Internet governance history and principles.
It really started somehow, the whole concept of Internet governance started officially, if you want, to be defined in the WIGIG final report, the world, this conference that took place over in Tunis. And it came out with a definition which was that Internet governance is the development and application by governments, the private sector and civil society in their respective roles of shared principles, norms, rules, decision-making procedures, and programs that shape the evolution and use of the Internet. That was the first real definition that was given and that was adopted at the United Nations WIGIG. Let's go to the next one. Is that the one? Aha. So, you really have 5 ways of Internet governance, and I've borrowed this slide from Wolfgang Kleinwester, who does this whole presentation at the Meissen School of Internet Governance, the European School of Internet Governance. And I think it quite shows quite easily the different phases that not only Internet governance has gone through, but also the Internet has gone through. The first wave was really the early days, the DARPANET, the military, the US military putting together this network, this experimental network. After that, it became more academic, and so you had a lot of universities that started working on development of the Internet from the 70s to the 90s. Then, from the 90s to the 2000s, the Internet became absolutely commercial, and we'll find out in a moment, of course, it's the World Wide Web, isn't it, that sort of created this whole commercialization of the Internet. After that, from the 2000s onwards, we started having a lot more video and mass media, which came onto the Internet, and we had a wave of all of this new things like YouTube and all of the different sharing sites, which basically we got in the 5th wave from 2010 onwards, with so much sharing, with what they were calling at some point the Web 2.0 or 3.0, and now there's not even a number, now it's just like everyone is sharing information with everyone else. So, geopolitics history. Well, let's start with, first thing, oh, there's a laser pointer here. Oh, that's good. Got 2 laser pointers. Okay. Interesting. All right, so the Internet. Technology developed a long time ago. It's got technical specifications, which are standards developed by the Internet Engineering Task Force. They're voluntary standards. You can use them, you cannot use them, it's up to you. You know, if you propose a service, it would be good if you use the standards, because that means you will be able to get your application and your computers to work, or devices to interact with other devices. And so it's quite important to note, these are voluntary standards. You can come up with other standards that are not within the IETF remit, that have not been developed there, but it's highly unlikely that anybody else will be able to actually work with your technology. Proprietary technologies like Skype, for example, do not have any IETF standards, but email and anything that requires diversified systems to talk to each other usually have a standard in the IETF. It's a multi-stakeholder development, so pretty much anybody who is interested in this can actually come in, participate in working groups in the IETF, and end up with writing RFCs. And I understand that there's one RFC that has come out of stakeholders from India. The Internet is a distributed network. It's a network of networks. It's not just a single owner network. There were lots of networks before that used to span the globe, before the Internet was really commercialized, that were owned by a single stakeholder. They did not succeed. They didn't succeed because it was closed and it was difficult to get on it, it was expensive, and this whole revolution of having a network of networks where any network following the rules would be able to connect really made the difference, and that's how the Internet started growing at such a rate. It's got a dynamic naming system, actually it's a domain naming system since the 1980s, and we'll go to that in a second. The ecosystem itself, it's due to, as I said, shared global ownership, development based on open standards. The standards are open. There were some times in the IETF when some standards were presented and there was some licensing problems and so on, and that was not really looked at with a positive hum. You heard the humming of approval in the IETF. There wasn't much of a positive hum in the room at the time. The unprecedented success comes because of these 3 things really: the open, the transparency, and the collaborative nature of it. The fact that you do not need, if you have a new application, something new to present to the Internet or to use the Internet, you don't need authorization from anyone to actually present this. And so this has really been a catalyst, a vector of innovation. it really all started in 1961. So you might have not heard of these people. J.C.R. Licklider was this scientist, super intelligent scientist and so on, that thought, well, you know what, one day the whole world will be connected. And it felt more like science fiction than anything else. He came up with the concept of the galactic network. It was at the beginning of the space race between Russia and the United States, and he thought, well, there also needs to be some kind of a network that will connect everyone together. Leonard Kleinrock is a professor who published a paper around that time on a concept of communication called packet switching, and that was totally unheard of. At the time, there was a system called circuit switching, where you would have circuits which were established end-to-end between a starting point and an end point. And he thought, well, if we digitize information and we cut it into small bits of information and send it through a network, and this information makes its way at the other end, and then it gets put all back together, then we might be able to put more than just one source and one endpoint on the same network. That was a bit revolutionary at the time. Nowadays, of course, we take it absolutely for granted because the internet uses packet switching throughout. But that was a significant move, because the moment this happened, they managed to start connecting computers together. And so in 1969, the internet started with 2 nodes, one at UCLA, one here, and very quickly, you look, September, December, a lot more machines started getting connected. And this was really the work of the DARPA-funded work in order to develop the internet. I think many of you have seen these diagrams. Then there was, so the whole work started building computers and so on, but it wasn't actually tracked very well. And Steve Crocker, who is now ICANN's current chair, has got a claim to history, which is effectively that he thought, wait a minute, if we're going to build something that's going to grow and going to have standards and so on, we need to find some way to register those things and to have papers that we can publish somehow and other people can comment on, so that we can start discussing things not just among ourselves in the office, because that's really how it started, in one office, or between our office and the office of 3 or 4 other institutions. But if there's more coming in, we need a system called, well, let's call it request for comments. And that's how the RFC came up. And so RFC number 1 is, you've heard it, request for comment. What is an RFC? First thing, hey, explain what it is that we're going to try and use. And so RFCs really are the standards of the internet. In 1971, well, he just came up with the RFC. Well, look at how many different nodes started appearing here. And each one had one computer that was connected, and it was all throughout the United States, scattered all over the place. And very quickly, there were applications that started coming up. And the first one was electronic mail. So it was Ray Tomlinson who in 1972 thought, you know what, we've now got this network which seems to be working and we can send information across. Why don't we actually put some kind of a software together, and we have an address from and to, and then we can send it, and we won't have to call each other by phone, we can just send it by email. And that's how he sort of sent the first electronic mail, which I think was something of like, do you get this? And the other side went, oh yes, we did. And then the whole system crashed, apparently. So, but it was a start. It was a start. And of course, very quickly, with this whole thing of email, it made for communication to be easier, and a lot more machines thinking, hey, this is quite helpful. And so the net started really growing very quickly. The network was still using a previous protocol called Network Control Protocol. And with the growth of the internet, it started becoming a bit difficult to manage because it had limitations with regards to capacity and with regards to scalability. And so in 1974, TCP/IP, Transmission Control Protocol, Internet Protocol, with a thing called IPv4 addressing, was designed by Bob Kahn, who was working for a company called Boll Beranek Newman, and Vint Cerf, who was at Stanford University. You might have heard of these people. I think they're sort of credited as being the fathers of the internet. And so you started seeing a real crazy growth about the internet, and you can see here that there's a lot more computers and it gets a lot more crowded. And so that was probably one of the last logical maps in January '75 before they ran out of space on a piece of paper. Actually, maybe this one was a little bit more, yeah. So 77, even more. And you can now seeing that names shown are IMP names, not necessarily host names. So it means that in some places, it might have been just a node and more than one computer connected to that location. So it really started growing quite quickly.
And since the previous slide, we were with nodes outside of US.
Oh yes, of course. This one, was it? Yeah, with Norsar with a satellite link. Look at that. Satellite link that would go to here. That was over in Norway, I think. And then there was a link over to London. So there was one node outside. Was there another one? There's also the other one that was really high, really far with the University of Hawaii. So the two different edges, there were like links outside the United States. That's a big thing. Thanks for pointing this out. So in 1982, it had grown so much, they ran out of space on the piece of paper, and so John Postel, this guy, and we'll speak about him in a moment, decided that, okay, maybe we can just look at the sort of main hubs and not link, the different computers. And in fact, we're going to just assign network names. So all of these were basically different networks, and that's how it became a network of networks rather than a network of computers, which was again a big step forward. Various ways of showing the network, but it started showing that it seemed that there were a lot of concentrations of the different networks of networks. So one was Milnet, which was used by the military. One was ARPANET, which was kind of joint military, but they also had some universities on there. And then there were these SatNet, which was based on satellite for countries outside. So you see Italy was connected, and other countries started getting some connections. And there was this wideband thing also, which was sort of, I guess it could be the precursor to wide area networks using radio waves and so on. But all of that started becoming very messy, and so they sort of gave up with doing internet maps. I think that Sebastian has got some pictures, I don't know whether you've put them in there, of the internet seen later, which is effectively like a soup or spaghetti bowl with so many things on it. The hosting, the way that, because you had IP addresses, so for each one of the computers that were connected on the net, they were numbers. Very difficult to remember numbers for humans. So they said, well, we need to have names for all of these nodes. And there was a thing called a host table, which had the names and the corresponding IP address. So the IP address was here, and then you had the name behind it. And you can see here you've got .mil, which was the military, and then you've got .arpa, and you've got a correspondence between this host and this host. And it was all updated by hand by one person, John Postel. Of course, when you have like 5, 10 new computers getting connected every day, it's fine. You just take your 15 minutes and you update the host file, press send, and it gets updated. Of course, if then you have 100, that's a little bit more work. If you have 1,000 a day, then it starts becoming unmanageable. And this is how they really had to start thinking of something else than just having a flat single host table for everything. And so they introduced the domain name system. Paul Mokapetris said, right, I'm going to try and find a way to have kind of a hierarchy where you would have top-level domains that would be run by a central organization. We'll call these sort of the root zone. And then each one of these top-level domains, so .mil, .gov, .com, these ones, each one would point to other servers with other organizations in charge specifically of these top-level domains. So .com, for example, would be run by VeriSign. And so then VeriSign would keep the database of all .coms and so on. And then if Apple was buying apple.com, then Apple would then be in charge of any subdomains in Apple. So www.apple.com and email.apple.com, this would all be defined by Apple themselves. And through this magic, the whole internet would still have this ability to translate from a name to an address to a number, but not a single organization needing to update absolutely everything. So you kind of spread the load across. So you ended up with, at the same time, you heard .com, .net, and .org, all that. Before that, it was all .arpa. So there was a time in 1988 where there was still these files that were working. So you had the host file that were working, and then you had the DNS that was working in parallel until there was a complete switch to make sure that everything was working right, because there were already a lot of computers and a lot of people using the internet at the time. Aside from this, there were also a number of people that couldn't wait to get an expensive, because it was expensive at the time, an expensive internet connection, because it required a leased line, it required all sorts of expensive equipment, mainframe computers and so on. And so, remember around 88, you started having the birth of PCs and sort of desktop machines, which couldn't get connected to the internet directly. But on the other hand, they could have a dial-up modem and they could call each other up. And that's how the Usenet and UUCP system came up. That was based on Unix-based machines, and so they would call each other up and then emails were transferred from one place to another. It was not the internet, it was to do purely with emails, but it actually came up as quite widespread across the world. And in fact, many countries that got on the internet later started having their first taste of global communication through computers using Usenet, and using one of the sort of the central nodes, UUNet, Usenet and UUNet. So in 1988, you had these large networks, Milnet, CSNet, computer science networks, all sorts of networks which sprung up. These were the biggest ones at the time. And you had 30,000 nodes, and that was already quite an achievement, from the two about 15 years earlier or something, or 20 years earlier to this. And they thought, okay, that's it. We don't need to, we can't really go to any more than that. But of course, in 1989, we had a separation of Milnet, because more people in the network means also you can't really check everyone who's on there. And they started getting hackers. Yay! And the military don't like hackers. So they said, right, we're going to completely separate ourselves. We'll have a few gateways to the internet. And we'll grow on our own side, and we'll, because we have real security issues with this. MCI started commercial email service on the internet, and it's funny because they were one of the first commercial email providers. And guess what? Who was their chief technical officer at the time? Vint Cerf. Yeah! So Vint was basically working for MCI, and he said, well, we've designed this thing, this is going to be big. We need to provide commercial emails. And the rest of the ARPANET and internet was paid for by the US taxpayer, mostly through the National Science Foundation. So things went into the academic phase. And so from 80,000 nodes in January of that year, it reached 160,000 nodes in November. So the growth became actually even faster. There wasn't any slowdown in growth. From 1990 to 1991, and this is the part which you don't really find in history books anymore, because everybody talks about the early days, Vint Cerf and all these people, but then this part, things started becoming commercialized, so there are not that many books that go deeply into exactly what happened in this sort of pivotal years, really, the early 90s. And so PSI, UUNet, so remember UUNet was this whole dial-up network. PSI was a commercial company, and ANS Core was also a commercial company, and they basically had fully commercial services. So if you had the money, you would pay them and they would connect you, and there would be both dial-up services and also leased line services. NSFNet was in full development, but they started introducing acceptable use policies, because NSFNet still had some commercial organizations that were working on research with the universities. But they started using email as well for their own business, because they thought, hey, this is a cost-cutting measure. And so the US taxpayer started getting a little bit twitchy about this. Successive governments and saying, we're going to lower the taxes, we're going to cut down on costs, and this thing is costing us money. We're going to have to stop that. So the rest of the world started connecting itself via various agreements. NSFNet became purely educational. There were only a number of services in 1990 to 1991. So there was email, as we know from the 70s, the early 70s. There was a thing called file transfer protocol. So when you had a larger file, you couldn't send it by email. You needed to do it through an FTP site. There's a thing called Gopher, and you'll see in a second, I'll show you what a Gopher page looked like. There's a wide area internet service, which was a kind of a search engine designed by librarians. I don't know if are any of you librarians? So you're working with libraries, and I have nothing against librarians, but at the time they were very cryptic. You go to a library and say, I'd like to find a book about this, and they start typing all these codes and stuff on the screen. You have no idea what it is, but it's all in their head. And that's a little bit what wide area internet search was. It was not a real search engine. You needed to come up with all sorts of parameters to be able to find what you wanted. And of course, once you found that information, then you needed to go into FTP and manually write what you were looking for, and it was very difficult, very cumbersome to use. There's Archie, which was kind of our archiving system, a system that was working with WAIS to make it a bit easier to find things. And there was Telnet, where you would just basically connect to another server remotely and log into that machine. And that's how basically you could actually do work from home and log into your machine and at work, etc. The services which you have now, these days, that are still around, you still have email, you still have FTP, you still have Telnet, and these ones pretty much disappeared. They were all text-based services. This is a Gopher, an actual Gopher page. Now I've got these pages because in these, so that's sort of early 90s, so 92, I was trying to put together an internet service provider in the UK. And I had to convince investors to put money into this. And they said, yeah, but what's the internet? And so I did some screen dumps at the time, you know, cut and paste from a screen over to a document. And I found the document recently. So I have these things which are genuine, actual Gopher pages from back in these days. And you can see, you know, you use the arrow keys and you can go down. You can either type the number and then press return and it sends you there, or you just use the arrow keys. But there's no such thing as HTML or hypertext. You can't highlight the text using a point and click, because this was still all very much text-based. In 91, they had the first internet exchange point that came together. Because all of these commercial networks were somehow connecting with each other, but it was sometimes a little bit cumbersome, because you remember there were some nodes that were in London, so you would have two commercial service providers in London. They would send email to each other and it would go all the way to the US and it would go all the way back. And of course, transatlantic links were very, very busy and crowded already at the time, because the internet was growing so quickly that they didn't even have the bandwidth and the connectivity that was strong enough across the sea, you know, and so there were natural limits and so on. I thought, okay, let's start putting some something together. And so PSINet, which at the time was one of the largest companies out there, UUNet and SurfNet, I'm told it's nothing to do with Vince Cerf, but they probably just took the name as such from him. And they came up with an access point, which was basically bypassing the NSFNet backbone, because the NSFNet basically said, no more commercial traffic, we want to be out of that. They established the whole concept of peering agreements, basically, where they all peer in a single connection, single location. And then comes 1992, with this guy who at the time was completely unknown, Tim Berners-Lee from CERN. You'd think, okay, a bit strange that a guy working in a place that does nuclear research suddenly comes up with this thing called HTML, and this thing called HTML, which is another language that you need to learn, which was a real pain for everyone to have to learn, because you had to, got more problems. But hey, you can now put pictures, you can now mix video, you can now have a text where you can use your mouse and you can click on the text and it sends you to another page. That's pretty good. That's a lot easier to use than Gopher. And so with the advent of PCs and Windows and what you see is what you get with, you know, Apple and so on, this really took off. And at the same time, as soon as he came up with this HTML language, the University of Illinois Urbana-Champaign had a few pretty clever students that decided to put together a browser, and they called it NCSA Mosaic. And so this is actually an actual screen print of the very early version, I think version 1 of NCSA Mosaic. And IBM, one of the companies that didn't have that much to do with the internet a bit later on, but very early on, looked at that, and there were only a handful of websites, and this was the IBM front page. And you can see that the then CEO there was really happy about connecting to the World Wide Web server. They were one of the earliest pages, you can see, 1994. So, you know, you had your little backload, home report, you know, it was a pretty simple browser, but it worked. You can see it's pretty grainy picture. That's because it was like that. It's not, you know, there's no high definition stuff back then. Remember, you couldn't really have very high def pictures because they would take too much time to load. So it was a little bit, but it was better than nothing. It was better than Gopher before. In the UK, the National Science Museum was one of the first, the National History Museum, sorry, was one of the first organizations that thought, hey, maybe we can show some of the stuff that we have. Maybe we can advertise for people to come into our museum. And so they started up this over pretty much at the same time in 1994. And then this big thing happened, which was, but you can also do things on the internet or have websites which have absolutely nothing to do with IT. And for example, here, brain scan images. You can start sharing this using the websites, so that really started growing. And this is, of course, well, the rest is history, really, regarding that. So, just a quick recap. 94. So we're talking about the year after that. The same students who had basically done NCSA Mosaic finished their project and said, hey, you know what, maybe we can do it like a commercial browser. You know, we can do a, what do we call it? Startup. Yeah, let's do a startup. Let's come up with a thing called Netscape. So they designed Netscape, and immediately, you know, it was much better than the first version of NCSA Mosaic. In 94, some people put together a system, a machine that would crawl through the web. And that was pretty much the first search engine, web crawler. And it was just like a few computers that would start going through, you know, start with one web page and then follow all the links and try and find out where it goes, and then find other websites and then find that, and then catalog it automatically. At the same time, two people, Jerry Yang and David Fallow, were publishing a regular list by email and also on Usenet, sharing it and calling it the Yahoo list of internet websites. And of course, you know, they did it by hand, and exactly the same problem as with John Postel. When they did it by hand, things grew so quickly that very soon it was very difficult for them to catch up. So they put together a company, Yahoo, which a lot of people looked at and thought, these people are totally insane, it's never going to get anywhere. But they got a lot of students to come in and work in the evenings, and, you know, do a little bit of cash to surf the net and put together a whole list of websites. And that actually was a lot more accurate than web crawlers, so a lot of people started using Yahoo at the time. In 95, so you're talking about more than a couple of years after the web really started, Microsoft woke up and said, well, maybe we need to have a browser as well. So they had Internet Explorer. The first version of Internet Explorer was terrible. It was pretty much like NCSA Mosaic, but, you know, and so most people were using Netscape. And then we started having competition in the search engines. And Alta Vista, which was an offshoot of Digital Equipment Corporation, DEC was a big hardware manufacturer, and they said, look, we've got all these computers, we've got all this computing power, you've got this web crawler that are running just a few machines. If we have big computers and we do a lot more surfing across and, you know, crawling across, then maybe we can have better search results. And that's how Alta Vista was created. In 96, in the UK, the first UK search engine was created. And then came these guys. You might have heard of them. Very strange name as well. But I remember a friend of mine tells me, like, oh, you're still using Yahoo? Oh, that's rubbish. You need to use Google. I was like, Google, wait. Oh, yeah, they're a lot better. And in fact, these two scientists were so good that their algorithms for being able to choose what was really good information, what was not that good information, made it very relevant. And when you were doing a search on Google, you really got what you wanted. And that's how Google suddenly became very big, very quickly. People left Yahoo, web crawler pretty much died. Alta Vista was sold because DEC, Digital Equipment Corporation, was sold. The new owners, Compaq, said, oh, we make computers, we don't do search engines. That was pushed aside. There were a few others. There was Lycos, there was Excite. Excite did some work with a network called Excite at Home. They failed, they collapsed. The internet is, you know, like a big sort of commercial world where you had companies that survived and companies that didn't. And the big difference that happened then is in 2005, the big step, video sharing with YouTube.
Just to add one point on that, it's interesting for the end user point of view that there are organizations who died since then, and there are other organizations who grew. But you never know when you will grow and when you will die. Then the next one, we don't know if Google will still, because for example, Microsoft was, and before them IBM, we were thinking IBM will take the world, and then Microsoft will take the world, and now we think that Google is taking the world. But we never know what will happen tomorrow, and we hope that people amongst you and your colleague will help us not to fall just into Google, but to something else. Diversity is important.
Yeah, Yahoo is going through a painful moment. Microsoft actually purchased a search engine in order to go into the search engine business. There was a thing called Hotbot. There was Hotmail and Hotbot. So these were sort of semi-independent projects that started up, and then Microsoft sort of went into it, and it turned into Bing.
What about ICQ?
ICQ,
right?
ICQ, yes, another one. There's so many, and you know, they've just disappeared or merged or been purchased by others and so on. Outside of the US, and you don't get that much data about what happened outside of the US. So this is a map. I used to track internet connectivity in the 90s. So this is a map that I took from the server from November 1993. What's in this cross color, and by the way, yeah, it was like that because we had so few colors to play with on our computers. It just looked all the same. So I thought, well, the red thing with yellow makes it very different from green, at least in the quality of the screens we had back then. So this is full internet connectivity, so what's in yellow and with the cross. In India, actually, there was just one node. But it still got to have that yellow color. It was shakti.ernet.in. And ERNET was the research network. It was all UUCP based, and Shakti was the central node that would receive email from the internet and then do dial-up across all of the cities across all of India. So they got in pretty early, and soon enough the UUCP dial-ups were replaced by leased lines, and you had full internet. But China didn't have that. China just had UUCP. They actually had their main computers call, the first link I think was calling a computer in Europe, long distance, and a few emails coming in and out, and you can see quite a few countries didn't have any internet whatsoever at all. And then 97, just you know, talking about 3 years later, bang, pretty much everywhere has got internet, except of course places of conflict. So for example, Afghanistan, they had other things on their mind than having to connect to the internet at the time. And North Korea, I think, is probably one of the only countries that still really doesn't have internet per se, apart from a couple of offices. And of course other places which basically were also having a few problems to connect, because it's expensive. It was still very expensive at the time. So May 1997, yeah. As the internet grew, there needed to be more IP addresses. I'm not going to have a whole thing about IPv6. I just wanted to give you an idea of what the difference is in size with regards to IPv6 and IPv4. IPv4 is the current addressing system that can have that many computers referenced at the same time. So there's that number of addresses. We ran out of these. I used to say we are going to run out of these. We have actually run out of these. IPv6 has been implemented, and many places are now rolling out IPv6 commercially, and it runs really well. You can have that many number of possible addresses using IPv6. So if this is a dot, here we go, the dot for the IPv4 space, this could be a representation of the IPv6 space. So we got plenty of room for the future. The end user principle, which I spoke about earlier in the internet, is really important. Any type of traffic is allowed. There's no filtering. Of course, now there is some filtering in some parts of the network, but there's no global filtering of content. And this is really a champion for innovation. You come up with a service and you can proceed forward without requiring a license to provide this service to the world. And therefore, as Sebastian was mentioning, smallest startup companies can become really big very quickly. They can become unicorns. That's another term that they've come up with. New business models, you can see, you probably know all these companies, and new community spaces. There's a lot more than 500 million users. I've given up on finding out how many. MySpace has pretty much disappeared now. Google Plus, what's happened to Google Plus? Is it still around? Oh, maybe it is. Is it one part of Google that died a painful death? I don't know, it's still there. But there are a lot of things were completely changed in the world because of the internet. The CDs, the music thing, you know, so music sales. So, you know, back in the 70s, that's before most people here were born. Well, I was around, but you know, they still had this thing called 8-track. I've never seen one of these. Then they had the cassette tape, which replaced the 8-track, and you can see the sales grew all the way until 1988, where there was the maximum number of, you know, was it MCTs, isn't it? Micro cassette tape. It's really cool. You can put it in the dashboard of your car, and it would run, even though there was a bumpy road and stuff. You had the cassette single, which died a painful death very quickly because it was just useless. And then you had, at the same time, you had all of this LP and EP, you know, the vinyl discs. Yeah. I see the older generation going like, yeah, I remember that. I've got a collection of these. Like see the younger people go like, oh God, this stuff that Dad has got, oh boy, it doesn't work, it's scratchy, it's terrible. Anyway, it, as you can see, there's some kind of a way, it died in a way, but what we are missing, because these two are actually stacked on each other, is this. This is where there was a really huge market that grew very, very far, and that's the CD. And we're talking about CD and of course DVDs that using the same technology and so on. That pretty much replaced the LPs, that replaced the cassette tape. But as you can see, it reached its peak somewhere in the middle, I think it was the mid-90s or something, yeah, 1999, end of the 90s. And then it decreased itself. And that's of course the time when more and more people were on the internet, and you've got all of this music video which grew a little bit and then came back down. And you start having these downloads over here, which start growing. And of course, now pretty much everything is downloaded. The market for CDs and DVDs has decreased so much. Same thing also for the internet connectivity. And if you stop internet connectivity, you might have heard quite a while ago. It was a few years ago actually, when there was some trouble, political troubles in Egypt. And the Egyptian government asked for the internet to be cut. So you can see the traffic that was going on, and so people wake up, so you're in the middle of the night, you've got a few people that use the internet at 4 a.m. and then it grew and grew and grew, and then at 2 p.m. and then suddenly the internet was cut and there was a complete drop to 0 by 6 p.m. That's the traffic in and out of Egypt. It actually was found to have cost $90 million because there are companies that use the internet. And Egyptian companies, a lot of Egyptian companies that do back office work, and when the internet was cut, well, that's it. You can go home, everyone, or you can go to Tahrir Square and demonstrate if you want to. But no work for today, sorry. Again, this was also from a few years ago, a study that was done in UK about the growth of the internet and how much weight does it have on the economy. Those figures now looked really big at the time. They're probably even larger now, because I think we're looking about 2008. And this was the actual things, and it was saying here real estate and business services. So these are the different sector sizes in the UK. And so the biggest sector in the UK is real estate and business services. So you're talking about the city, effectively. Financial services, etc., being just underneath that. Wholesale, retail, manufacturing, still very high. But you can see that the internet that's over here is actually reaching right over here. So it's a fifth position before health and social work, before construction, before education. And I gather that in India it probably is an even larger share of the GDP due to the advancement of all the services and I guess you can see the techno parks that spring all around India. I used to think it was only in Bangalore, and now it's so many different very, very advanced techno centers. It's really impressive. So yeah, it's changing the business world completely. Oh, change. Oh yeah, change. Well, throughout the years, having spoken to people for business plans and so on, and telecommunication companies in the 90s, and there was always a concern about change. Internet is changing everything. We're against everything. Now there's a fear about the Internet of Things. There's a fear about losing jobs because of the Internet. There's tons of fears about it. And I think that ultimately the lesson to learn is that the world is changing. It's changing faster than ever, and you shouldn't be worried about change. There used to be a time when in Europe, certainly, there were a lot of horse-drawn carriages, and there was a whole ecosystem based around horse-drawn carriages with inns where you could bring your horses and they would be fed, and you could get another change of horses, and then on the back you get your horses back and so on. All of that got wiped out with the automobile, and there was a lot of pushback against the automobile, so much so that in the UK the automobile, the sort of manufacturers of horse-drawn carriages lobbied the parliament. Don't know if you know this story? Anybody knows the story? No, they lobbied the parliament, and I think it was the sort of early 1900s. They put a law there because they said automobiles are dangerous. They can kill people. You can run over people with these things. Horse-drawn carriages makes noise, so people move aside. But the automobile, they don't make noise, so they don't move aside. So every automobile has to have a person walking in front of it with a red flag, announcing it, saying, "Careful, careful! There is a car coming." And of course, the car wasn't going very fast. The first cars weren't going very fast, but the moment the car's going a bit faster, the first casualty was the guy who was holding the flag who got run over by the car. And so it was pretty detrimental to the guys carrying the flag, and therefore they decided to scrap it, and that's how the car then took over. But this is pretty much the sort of stories that you get, and today you get a lot of legislation that some companies try to push for that go against the growth of technology and the advent of all of these new technologies. In some countries more than others. So I don't know what the situation is in India. I would imagine that with an IT sector that is so big and so dynamic, you probably don't have that problem, but some countries definitely have the problem. And I can certainly tell you in Europe, with some countries being very traditional and with regards to their old industries, they tend to be very careful about all these new technologies. What needs to be done? Well, you pretty much read it. You just have to embrace it and deal with it and embrace change. And Vint Cerf, we'll finish with a little quote from Vint Cerf, I guess, talking about the internet. So it's layered, it's end-to-end. It allows people to innovate free of any central control. And that's important. There are talks sometimes of having to license internet services, licensing of websites, licensing of applications. And that would really be slowing down innovation because of all the red tape involved. And potential, real potential for corruption as well, because the moment you have a blockage point, then people try to go around it and find other ways to push through. And the fun part that he said here, science fiction doesn't remain fiction for long, and certainly not on the internet. So when you do regulation and you put regulations together and legislation and so on, which is needed. I'm not saying you need to have no legislation, no regulations whatsoever. You have to be careful when you do that you do not actually cut the branch that you're sitting on, and you don't have something that is so restrictive that it will actually kill innovation and that it will actually hang you at the end and play against you, whilst your competitors, remember the internet is borderless. If you come up with something that's very restrictive, all the work is just going to go abroad, and it's going to go somewhere else where it's easier to work. So that's, I think, the last one that I can show for today.